Welcome back to another coding video. Today we're going to be doing the staircase challenge from HackerRank, and we'll be doing it in C#. So to summarize this problem, we are going to be given a integer n, and we're expected to output a staircase to the console that looks like this. The staircase is made of these pound signs. The staircase is supposed to be right aligned, and our integer denotes the height and the width of the staircase. So we'll only be dealing with square staircases in this challenge, which makes it really not too bad. So hopefully we can knock this out, and I'll show you guys a handy trick, a way that I use to kind of solve these weird star trees, is what I've heard them called as, even though these ones are pound symbols. It seems like, at least where I went to school, a lot of the first programming class was just having you make a whole bunch of weird different versions of this. And so hopefully I can show you a trick to kind of figure these out, something that helps me think about them. So other things to note, I guess, are constraints is that n is at least 1 and less than equal to 100. And the first row is going to have 1, and the last row is going to have no spaces. Okay, so let's look at, I've prepared a little example to try and describe how I go about solving these, because as you can see right here, this is a pretty common thing to see on like a test in your first programming class. They'll have you just output weird shapes to the console to see how well you understand loops. So that being said, the basic idea is that you have a nested for loop that goes over each row and column, and then you decide whether or not to output a pound symbol or a space. So with our challenge, we're going to be doing like a left aligned pyramid like this. So one way that I like to think about it is actually just like you would do it in math. So the first thing that I try and identify is if there's any sort of like a line that I can pick out in any of these. So if we look at this A, I can kind of see that there's a line kind of like at the top of this triangle. With B, there's a line kind of like this. And we're not really paying too much attention to the edges on these. So one right here, one right here. These more complicated examples, you can see there's one diagonal and then one kind of cross in the bottom. So the first thing that I like to do is to think about how to describe that line just using regular math terms. So this one's a pretty simple one to think about. We have our rise over run is just going to be 1, so our slope is going to be 1, and then our y-intercept is going to be the origin, which is going to be 0, 0. So if I can draw a straight line, it's going to go up kind of like this. So this line's probably pretty familiar to you. It's just going to be y equals x. And I know you probably didn't expect to be watching math in this video, but bear with me, it will make sense. So in this example, we're going to be doing these like pound symbols, right? So we're going to be using this line to kind of facilitate the decision process of whether or not we should be outputting a pound symbol or a space to the console. So now that we have our line, we want to describe not just a line but an area in this case. We want the area below the line, and then we also want the line included, because if you remember back to our picture, we can see that the diagonal right here is included. So one way to describe this would be all of the places where x is greater than y or equal to, because we want our line to be included. So that's going to give us our area. So just picking a couple of points to prove that this is going to work, we'll have 0, 0. So 0 is less than or equal to 0. Yep. So that one's going to be included. Then we'll have 1 and 1. And we can see that pretty much anything on this line is going to be chosen. We'll do x equals 4, y equals 0. So 4 is greater than or equal to 0. So that point's going to be included. Let's do that one, just random. So 5 is greater than or equal to 2. Yes, that holds true. And we'll pick one out here. So when x is 1 and y is 6, we can see that 1 is not greater than 6. So this point will not be included. So knowing this, let's go into the code, and instead of using some standard loop variable I and j, let's change these to be x and y, and then you will see, oops, I just did that out of habit. So we're first going to want the rows. So the rows are going to be y. We'll start that at 0. Y is less than n, y plus plus. And then we'll nest our other one. X equals 0, x is less than n, x plus plus. Okay, so now all these loops are doing is going to be going over every single coordinate in our grid, if we're sticking with that example. So now all we have to do is, within this nested loop, we have to decide whether or not to output a space or output a pound symbol. So we know we output a pound symbol when we are within the area that we have described by x is greater than or equal to y. So having named these variables the same way that you would see them in a math coordinate system, we can pretty much just write exactly what we wrote in the math. If x is greater than or equal to y, then console write pound. And if it's not, then we will write a space. So the last thing we need to do is, so this is when the columns are running. After each column is done being decided, what we want to do is we just want to end the line. So I'll say right line blank. So what that's going to do is we'll say space, 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 pound symbol, and then we're done with this row, so new line. Okay, so let's go ahead and run this code. And haha. So we have come to the only flaw in the analogy, and that is that our y-axis is actually flipped. So this is because in math you typically see your y-axis starting at 0 from the bottom and then increasing near the top. In computer science, when you're talking about arrays, it's the opposite. So our first row is going to be 0, second is going to be 1, third is going to be 2, so on and so forth. So you can see that it increases as it goes down. And so there's a couple of ways that we could fix this. We could go in and mess with our logic right here at what goes on in the middle. I think that kind of gets really messy. It's really easy to lose track of where you are and what you were thinking about. And so I think a lot easier way to do it is to essentially flip your axis in the parameters So instead of going from 0 all the way up to n minus 1, we'll be starting at n minus 1, and we'll be going to 0, and we'll be subtracting. So let's go ahead and run this. And there we go. So we passed the test case. So what we pretty much did was, instead of going from 0 to n minus 1, we started from n minus 1 and we subtracted until we got to 0. And that essentially flips our y-axis. So if you remember to flip your y-axis and not your x-axis, then you can pretty much figure out your shapes using math, right? So let's look at some of these and I'll show you what I mean. So let's see here. So A, how would we describe this? Well, we can see that our y-intercept is going to be whatever n is. In this case, 1, 2, 3, 4, 5, 6, 7, 8. So our y-intercept is going to be 8. And then it looks to me, I'm not going to bother counting it, but it looks to me like we probably have a slope of -1. So, you know, the line right here would be y is equal to -x plus 8, or plus n if we wanted it to be generic. So because we're getting everything below the line, we'll say that we want this when x is greater than, when -x plus 8 is greater than or equal to y. So we could go through these other ones, but they're going to be pretty similar. See y-intercept of 0 here. We have positive x. This is pretty much the same one that we did. The only difference is that we're going to be taking everything that's above the line instead of below the line. This one's going to be basically the same as this, but our sign's going to be flipped so that we get everything above the line and not below the line. So these more complicated ones are actually easier, I think. They look weird, but if we follow kind of the same way, they're even easier, I think, because we don't actually have a region we're trying to go through. We have an exact line. So for this one, we can see that the only times we want to output it are when x is equal to 0, when x is equal to n, when y is equal to 0, and when y is equal to n. And so looking at a couple more of these, we can see this one looks like -x plus n, like we figured out in this one. And then when y equals n and y equals 0, this one's going to be y equals x, this line, and same thing, y equals n, y equals 0. Here we have both of them, and then here we have a combination of all of those. So that is it. I don't really know why they have you do this all the time in beginner programming classes. Maybe it's just to stretch your brains because they are kind of tricky to think about. But I think thinking about this in terms of math and then translating it into programming is a little bit easier. When I start off just looking at the code, I still to this day can get pretty confused pretty fast. Some of the shapes get really wonky, but doing this really helps me. If you have another tip, feel free to comment below. Thanks for watching and have a nice day.